Hi there, welcome to my channel. In this video, I'm going to discuss about the solution for single number problem. Let's look at the problem description. We are given an integer array nums where every element appears 3 times except for one, which appears exactly once. We have to find that single element and return it. Also, we are expected to implement this solution with a linear runtime complexity and with constant extra space. Let's take a look at the example one. So here the input nums array has 4 elements. In this, number 2 appears 3 times and number 3 appears only once. So we have to return 3 for this input. In the case of example 2, the nums array has 7 elements. In this, 0 appear 3 times, 1 appear 3 times, and the number 99 appear only once. So the output for this case is 99. The constraints for this problem are the length of the array is ranging from 1 to 30,000 and the individual elements value is ranging from minus 2 power 31 to 2 power 31 minus 1. And each element in the nums array appears exactly 3 times except one element which appears only once. Let's look at the approach to solve this problem. We are given the input array with 4 elements. In this number 2 occurs 3 times and number 11 occur once. For this input, 11 is the output. The brute force approach is to count the number of occurrences of each number and store it in the hash map. Okay, so in this case number 2 occurred 3 times, so 2 is the key and the frequency is 3, and number 11 is the key and the frequency is 1. Once this hash map is built, we can walk through this hash map and find the entry with the frequency 1. In this case, the key 11 has a frequency 1. So we can return number 11. But for this, we need to allocate space for this hash map. And as per the problem description, we are expected to solve this problem with constant space. So another approach we can use to solve this problem is doing a modulo 3 addition on all the numbers in the input array. Okay. For example, for this input array, number 2 is 0010, 0010, number 11 is 1011, 0010. Okay. If we do modulo 3 addition, if we add all the least significant bit, so we have only one bit set. So the sum is 1. But in the case of the second bit, if we add all, there are 4 modulo 3, 1. So this bit is set to 1. And in this case, all are 0. So the sum is 0. In this case, there is only one bit set. The sum is 1. So the sum we get is 11, which is the number that occurs only once. So we cannot directly do modulo 3 addition using any bitwise operators. So we can build this solution on top of the modulo 2 addition using the bitwise XOR operation. Okay. Basically, we maintain 2 bit mask. Okay, single bit mask and double bit mask. The single bit mask keeps track of the bits which are set odd number of times so far. For example, iteration 0, we process the first 2. Here this bit is not set, so 0, and this bit is set and this is the first time we are seeing, so odd number of occurrence of this bit. So this bit, the second least significant bit, will be set, and in this case it is 0 and it is 0. Okay, and when we process the second element in the array, which is 2 again, so in this case the least significant bit is 0, so this will remain 0, but this bit is 1. But so far we have seen 2 numbers. In those 2 numbers, the second bit is set, so the total number of occurrence is 2. So in this case, we have to clear this bit by doing the XOR operation of this number with a single bit mask. Okay, and then here these 2 bits will be 0. Again, we have to do the XOR operation on this bit mask with the same number. So 0010 XOR 000 will be 0010. So this bit will be set because so far we have seen two numbers which are these two bits set. So that's why the second iteration this bit will be set. So likewise for every number we do the XOR operation with the current value of the single bit mask. In addition to update the single bit mask with the XOR value with each number in the array, we also need to negate the bits which are set in the double bit mask because we are interested in the number which occurred only once. Okay, but for the case where the number occurred third time, we should remove that number from the output. For example, the number 2 occurred third time. So when we see that number, we should not include that in the single bit mask because that number occurred third time. To exclude that third occurrence, we negate the double bit mask and AND that with the single bit mask. So this operation will clear the bits associated with the number that occurred third time. After updating the double bit mask with the XOR value between the double bit mask and the number, we also need to clear the bits which are set in this single bit mask. Because at any point, either that number can be into this single occurrence bucket or the double occurrence bucket. Okay. To do that, we AND the double bit mask with the negated value of single bit mask. Okay. So that way we make sure we keep track of only the bits which are occurred 2 times. Okay. So if we repeat this for all the numbers and finally we get the output of modulo 3 addition, and which is the value of the number that occurred only once. That's what I have written here. First we initialize the single bit mask and the double bit mask to 0 and traverse the nums input array. Each iteration we update the single bit mask with the value of single bit mask XOR the current number. And then for each bit set in the double bit mask, we have to clear the corresponding bit in the single bit mask. This is to handle a case for clearing the bit which occurred third time. Okay. And then we update the double bit mask with the value of double bit mask XOR number. And then for each bit set in the single bit mask, we have to clear the corresponding bit in the double bit mask. This is to make sure we set bits which occurred even number of times so far. And finally, we return the value in the single bit mask, which is the value of the number which occurred only once. Let's look at the flowchart. Input for this procedure is a nums array. First we initialize the single bit mask and the double bit mask with value 0. Then we enter the for loop. We process each number in the input array. First we perform the exclusive OR operation between the single bit mask and the current number. Okay, and update the single bit mask value. Next we clear the bit in the single bit mask if the corresponding bit is set in the double bit mask. This is for the case where the current number occurs third time. Okay, so for that we negate the double bit mask value and AND that with the single bit mask and update the single bit mask value. Next we perform the bitwise exclusive OR operation between the double bit mask and the current number and update the double bit mask value. Then we AND the negated single bit mask value with the double bit mask. This is for ensuring only the bits which occurred even number of times so far. And we repeat this process and finally we return the single bit mask value as the output. Let's move on to coding. First I initialize the single bit mask variable with value 0. Next I initialize the double bit mask variable with value 0. Then I write a for loop to process all the numbers in the input array. Each iteration I set the bit in the single bit mask variable if the count of numbers with the corresponding bit is set so far is odd. We can achieve this by doing the exclusive OR operation between the single bit mask value and the current number. Next, I clear the bits which are set in the single bit mask on the third occurrence of the current number. This is done by ANDing the negated value of double bit mask with the single bit mask value. Next, I set the bit in the double bit mask if the count of the number of numbers with the corresponding bit set is even. This is by doing exclusive OR operation between the current value of the double bit mask and the current number. Next, I clear the bits in the double bit mask that is set on its first occurrence. Okay. This is done by ANDing the double bit mask value with the negated value of single bit mask. Then at the end I return the single bit mask as the output. Next I am going to run the test cases. All the tests passed. Next I am going to submit this program. Cool, this program is accepted. Next I am going to do the code walkthrough with sample input. We are given input nums array with 4 numbers. 2 occur 3 times and 11 occur once. Expected output is 11. Okay. First we initialize the single bit mask and the double bit mask to 0, and I show the values in the input array in a binary format, and then we enter the for loop. Iteration 0 we process number 2. Okay, by performing exclusive OR with single bit mask which is currently 0, so we get 0 0 1 0 as the output of the exclusive OR operation. So the single bit mask will become 2, and then we negate the double bit mask current value and AND with the single bit mask. So currently all are 0, so the negated value will be all ones, and with 0 0 1 0 will give again 0 0 1 0. So when we leave this iteration, the single bit mask value is 2. Next we update the double bit mask value by performing the exclusive OR operation with the current number. After this operation, the double bit mask will have 0 0 1 0, but we have to make sure the bits which are set in the single bit mask should not be set in the double bit mask. We AND the negated value of single bit mask with the double bit mask. So the negated value of the single bit mask will be 1101. Okay, with 0 0 1 0 of the current value of bit mask will result in all zeros. Okay, so that's why when we leave the iteration 0, the single bit mask has value 2 and the double bit mask has value 0. And then in the iteration 1 we process the next number 2. Okay, we perform the exclusive OR operation with the current value of the single bit mask. Then we'll end up getting 0 because the current value is 2. Exclusive OR with the number 2 will result in 0. Okay, and then we again update the single bit mask with the negated value of double bit mask. We again get value 0. So that's why the single bit mask value is 0. Next we perform the exclusive OR operation between the double bit mask and the current number, which gives 0 0 1 0, and then we AND the double bit mask value with the negated value of single bit mask. So the single bit mask is 0, all negated value is all 1. So 0 0 1 0 with all ones and with all ones will give 0 0 1 0. So when we leave this iteration, the single bit mask will have the value 0 and the double bit mask will have value 2. So if you look at it, at the end of this iteration, this bit is set because these two bits are set, which occurred 2 times. That's why this bit is set. But in this case, we process only one number and only this bit is set. So that's why the single bit mask is set in this case. In this case, that is shifted to the double bit mask. In the iteration 2, we process the number 11. Okay. So here we perform the exclusive OR operation with the current value of the single bit mask. So 1011 exclusive OR 0 will give 1011. Okay. And then we AND the single bit mask value with the negated value of double bit mask. Then the double bit mask has value 2. So the negated value will be 1101. So that's why this bit will be cleared. So we get 1001 as the single bit mask value after performing this operation. Next we do the exclusive OR between double bit mask and the current number. So the double bit mask value is 0010, exclusive OR 1011. We get 1001 as the double bit mask value. But because of this operation, we by ANDing the negated value of single bit mask, we get 0 as the double bit mask value. So that's why when we leave this iteration, the single bit mask value is 9 and the double bit mask value is 0. The last iteration, we process the number 2. Okay. So we do exclusive OR operation between this number and the current single bit mask value. So the exclusive OR operation will give 1011 as the single bit mask value. Okay. And then we AND the negated value of double bit mask with the single bit mask. So the current value of the double bit mask is 0. So ANDing 1011 with all ones will result in the same value. So that's why the single bit mask will have the value 11. Next we do the exclusive OR operation between the double bit mask's current value and the number. The current value is 0 and the number is 2. So the exclusive OR operation will give 0010. Okay. Next we have to AND the double bit mask value with the negated value of single bit mask, which result in value 0. So when we leave this last iteration, the single bit mask has value 11 and the double bit mask has value 0. The single bit mask has value 11. That is the number which occur only once in the input array. That is an expected output. Next I am going to do the time and space complexity analysis for this solution. Time complexity of this procedure is order of n because we have to process all the numbers in the input array. So for example, in this case, we have 4 numbers in the input array. So this for loop performs 4 iterations. If there are n numbers, this for loop performs n iteration. So that's why the time complexity is order of n. Space complexity is order of 1 because we are not allocating any additional space in this procedure. We use only 2 variables. So the space complexity is order of 1. Thanks for watching this video. Have a great day.